Good day everyone, and especially to you Ma'am Dizon. I am here today for our recitation in AG104 Activity 4.
Problem 2.12. Cite along a C2C band of propane and draw a Newman projection of the most stable conformation. Draw a Newman project of the less stable conformation.
The most stable conformation of a substituted alkyne is generally a staggered, one in which large groups are as far away from one another as possible. The less stable conformation is generally an eclipse, one in which large groups are as close as possible.
Next, problem 2.18. Give IUPAC names for the following cycloalkynes.
Letter A. First, find the friend. Count the number of carbon atoms in the ring. So they have 6 carbons, named as a substituted cyclohexane. The substituents present in the structure have 2 metal attached to carbon 1 and 4 in the cyclohexane parent. The substituents will be 1 and 4 dimethyl. The final name will be 1 and 4 dimethyl cyclohexane. Letter B. First, find the friend. Count the number of carbon atoms in the ring. So they have 5 carbons, named as a substituted cyclopentane. Next, identify and number the substituents. The substituents present in the structure have 1 metal attached to carbon 1 and 1 ethyl attached to carbon 3 in the cyclopentane parent. The substituents will be 1 metal and 3 ethyl. The final name will be 3 ethyl and 1 methyl cyclopentane. Letter C. First, find the parent. Count the number of carbon atoms in the ring. So they have 4 carbons. Name is a substituted cyclobutene. Next, identify and number the substituents. The substituent present in the structure have 1 isopropyl attached to carbon in the cyclopentane parent. The substituents will be isopropyl. The final name will be isopropyl cyclobutene. Next, problem 2.21. Prove both cis and trans isomers of 1 and 2 dibromocyclobutene. Previously, constitutional isomers have been defined as molecules that have the same molecular formula but different atom connectivity. In this section, a new class of isomers, stereoisomers, will be introduced. Stereoisomers are molecules that have the same molecular formula, the same atom connectivity, but they differ in the relative special orientation of the atoms. Cycloalkynes are similar to open-chain alkynes in many respects. They both tend to be nonpolar and relatively inert. One important difference is that cycloalkynes have much less freedom of movement than open-chain alkynes. Open-chain alkynes are capable of rotation around their carbon-carbon sigma bonds. The ring structure of cycloalkynes prevents such free rotation, causing them to be more rigid and somewhat planar. The substituted cycloalkynes are one class of molecules that exhibit stereoisomerism. 1 and 2 dibromocyclobutene. Dibromocyclobutene can exist as 2 different stereoisomers. The cis 1 and 2 dibromocyclobutene and trans 1 and 2 dibromocyclobutene stereoisomers of 1 and 2 dibromocyclobutene are shown below. Both molecules have the same molecular formula and the same atom connectivity. They differ only in the relative punctual orientation of the 2 bromines on the ring. In cis 1 and 2 dibromocyclobutene, both bromine atoms are on the same face of the cyclobutene. The 2 bromines are on opposite face of the ring. Stereoisomers require an additional nomenclature prefix be added to the IUPAC name in order to indicate their spatial orientation. The substituted cycloalkynes stereoisomer are designated by the nomenclature prefixes cis Latin meaning on this side and trans Latin meaning across.